Looks good. All right, so good morning and welcome to Break from the Past, Why CNFs Must Move Beyond the NFV Mentality. My name is W. Watson. I'm with Voc Co-op, and I'm joined by Jeffrey Salines, who's with Charter Communications. And I hope that you enjoy what we have provided for you today. So on our agenda, we're going to talk a bit about cloud native ideology, and we're going to have a little fun with some buzzword bingo. And then we're going to talk a bit about the SDN space. And then we're going to talk a bit about the service provider pain and different ways to address that pain using NSM in the development process. So it's going to be a lot of talk about regular software development processes there. And so cloud native ideology, what does ideology mean, right? So ideology can have many definitions ranging from a pejorative term for that which is wrong to a fantasy that covers inconvenient truths, right? So the term cloud native has many ideological definitions, starting with no one knows what cloud native means, which falls under that which is wrong extreme, right? And then on the other extreme, we tend to treat cloud native as a panacea, which falls under the fantasy category, right? So you have a spectrum there. Okay, so to me, a clue to how to reason about cloud native ideas, and this kind of runs along the line with the talk that we just went through, which I found very interesting. A middle ground can be found in the paper Programming in the Large versus Programming in the Small by Frank de Riemer and Hans Kron, written back in 1975. A problem that's been plaguing programming for 45 plus years is figuring out how to reason about, define, and direct several programs, components, or modules as a system. When we look at cloud native principles as a whole, it's analogous to reasoning about programming in the large. But various domains of cloud native, such as containerization, CI/CD, orchestration, observability, service meshes, networking, etc., can be associated with programming in the small. Some aspects of the higher level are found in the lower level and vice versa. So on this view, with respect to networking, the right question to ask might be, how do we take cloud native principles and apply them and apply them to the individual domain of networking? For cloud native in the large, networking often means service mesh networking, such as service discovery, health checking, routing for REST services, load balancing, authentication and authorization, and even the generation of observability metrics and tracing, right? So that's kind of like the service mesh idea of what a data plane is, and not for this crowd, but more for the traditional service mesh. And those are mostly layer 7 concerns that address the networking of components or modules as a system. For cloud native in the small, networking concerns go down to layer 2, with even implications that might go down to layer 1 for cloud native in the small. In the words of Ed, the packet is the payload. So how do we address this? Move this out the way here. Okay. All right. So, how is it that we address this this confrontation of the higher level and the lower level, and maybe some of the conflicts that happen with trying to define terms and such? right? The result of really any critique of an architectural offering should really be the trade-offs of that offering. Okay, so critiquing the promise of cloud native should be no different. We should force ourselves to define what we mean when we use cloud native terms. And we can do this by playing something like buzzword bingo during our talks, papers, and conferences to keep us from relying too heavily on buzzwords and extreme ideological positions. When hearing a description of cloud native networks, try asking yourself the following questions. Does this description sound like a high-level enterprise application concept, and does it address my networking challenges? Is it a traditional SDN networking concept with new names, essentially rebranded? And are the terms being used defined well enough? I think those are really, that's like the gauntlet I think that we need to lay down. And within this group, we kind of lay down that gauntlet pretty well. Within the larger like CNCF group and some of the other communities, Kubernetes communities, I think we need to lay down the gauntlet a little bit better than what we've been doing. And now I'm gonna hand off to Jeffrey.
Okay, can you guys hear me okay?
Yeah.
So yeah, NFV and SDN, like I'm going to talk a little bit about some of the challenges I've hit from working on both the vendor side and the provider side. Just kind of go over, you know, what I think was lacking based on the ideology that Watson just laid out. And then, you know, this kind of leads into why we started to chase something like network service mesh. So, I mean, first of all, in my opinion, SDN is the champion of all buzzwords. I guarantee you, let me see how many people. We have 79 participants right now. I bet if I asked all of you what SDN was, I'd get 79 different answers. You know, is it an API abstraction that I write my own custom Python on top of? Is it, you know, some SDN controller that pushes open flow route injections and stuff and messes with somebody's route table? Is it just orchestration? You know, where does the policy versus configuration management fit? Like, it's just a completely overloaded term. And at the end of the day, I have to ask, you know, what problem were we solving? I think the answer people would give is that it was supposed to reduce complexity, but I feel like it did the opposite personally. We get like these central controllers that are supposed to do everything, and then we get into this endless loop of how many southbound adapters do I need to develop to actually talk to all these different vendors. And that's kind of like one of the key things too, is me as a provider, I consume technology from lots and lots of different telco vendors. Name an SDN controller where I can like go in and talk to 4 different vendors, switches, and program, you know, data centers, fabric path or something. Like, it's next to impossible. I can do it with their stuff, but I can't do it with someone else's stuff, right? Like, it's almost always a greenfield experience, and my brownfield is always forgotten. You know, sorry you spent all that money on those legacy switches, but you need to throw them out and buy our whole new systems. That way you can do quote unquote SDN. Then you have virtualization, like all 50 shades of it. I mean, this one is even more challenging, and this is kind of why I think a lot of providers are looking at cloud native, but like, there's a lot of cool ideas that just didn't pan out. We basically just kept the exact same model we had with CNFs, and we added a whole bunch of complexity. I took one packet core line card, and I directly swapped it out for one x86 rack mount. I put a single VM on it, and for all intents and purposes, I built an appliance, which I have to ask, if I'm gonna go with an appliance-based architecture, why wouldn't I just get a use case appliance that, you know, has a known set of parameters, a, you know, vendor-provided configuration guide, and is, you know, something that is easy to open up a TAC case on, like one TAC case, right? Like, I go and I talk to the packet core people, they know that CLI inside and out, they have direct access to the BU. Move it to the virtualization space, something breaks in. Do I talk to the packet core group? Do I talk to the Nano group? Do I talk to the virtualization group? Like, which layer of this stack am I actually troubleshooting right now? And then there's, the things that most vendors get a little cross at me about when I bring up, and that's the fact that we all know that the vast majority of them took their PNF code, forklifted it, shoved it in the VM, and said we're virtualized. I feel like that lesson carried over. I do see a lot of, quote unquote, cloud native network functions that have been somewhat re-architected, not all of them, but this resulted in a lot of interoperability errors, things like that. So basically, that very bottom thing, the ROI, like, where was it, right? Like, I was promised that NFV was going to, just drastically reduce all my OpEx. I think all it did was shift the OpEx. Like, there has been successful NFV deployments. I'm not saying there hasn't. There's people who have mastered this, but at the end of the day, Watson talks about like the principles and the ideology of cloud native, and one of the biggest things is this declarative approach to how you consume services, right? Like, I put it into key terms at the beginning. We have this concept of Sarah. She is this, angelic software developer who just puts out perfect containers everywhere and we all consume it. And then we have these sneaky network people, as Ed likes to call them, and they're basically the bane of Sarah's existence. They literally exist only to impede everybody else's problems because we care about things like subnets, route injections, things like that. And we want to know how stuff works. And I think that one of the main challenges with like NFV is the fact that at Sarah's level, everything was still completely imperative. If anybody's ever taken the time to fill out a network service descriptor or a VNF descriptor, it's an arduous process, and there is 8 million things that you need to account for to deploy, this setting. So I mean, you didn't really abstract away any of the complexity you had when you had PNFs, when you were still going in and manually configuring everything. You just took all of that manual configuration and you shoved it into a text file. So, this is one of the things that we consider, like, as we're looking at why would we move to a cloud native approach, and specifically look at, how do I do cloud native networking, as Watson put it, versus forcing the cloud native space to conform to what I used to do in my previous iterations of, virtually and physical networking. Anything you want to touch on the diagram, Watson?
Nope, that sounds good. We'll switch over to the next piece here. So I'm going to go a little off the cuff here. So I'm, a little bit about me. I'm really just a pure programmer. I've been programming since I was 12 years old for over 30 years. And one of the things that I'm drawn to is pain, like a user's pain, other developers' pain, so on and so forth. And I attended a conference, Open Source Summit, maybe 3 or 4 years ago. And there was someone from TELUS that gave a presentation. They were a service provider in Canada. And they were just talking about this pain. And then all they put on their presentation were all things that had to do with just really the development process. They weren't really talking a lot about the technology, other than that it didn't satisfy what they wanted. And then I keep hearing this in the different environment, the different conferences that I'm at, whenever I talk with some service provider, even Jeffrey, the pain that they talk about, it's different than a lot of what within the, let's say, the cloud native community, what the pain that they're trying to address, right? So from my perspective, what I've seen for the past 2 or 3 years, as far as the pain that I've seen, service providers have the desire for speedy deployments and changes the code with minimal toil, right? So they want to apply security patches without having to upgrade everything in lockstep, for instance, right? We don't like development cycles or rollout cycles that are 6 months, or it's wild to me, but someone laughed at that when I was saying 2 or 3 months as far as a rollout. They're saying try 1 year. And being a developer, that just sounds extremely wild to me. That's going back to the 90s or early 2000s, right? So like I was saying, service providers, of course, they want a resilient infrastructure. Of course, networking needs to stay up. The network needs to stay up all the time. And then what's funny is that what many service providers, what they want or what they think they want is from cloud native is Kubernetes, right? So Kubernetes has the benefits that come with managing the lifecycle for your applications. Running Kubernetes seems to legitimize the containerization process that you may have previously done on your workloads. But there are problems with just adopting Kubernetes without changing your development process. And that's what I'm going to be talking a lot about. This premature adoption really gets the cart before the horse. The many desires of the service providers are solved higher up on the CNCF's cloud native trail map, which I'm showing here. And what you actually need, and then I'll go over here. What service providers actually need are the properties of Agile, the properties of speed, of deployment, and the ability to change code with minimal toil. This is supported by a strong continuous delivery process, which is often skipped on the trail to a cloud native, right? With continuous delivery, you have a process, a pipeline, right? That applies a series of tests at different stages. The first stage creates an artifact from the source code. The second stage tests the integration of that artifact with other artifacts, configuration, and resources in a test environment, right? And then the third stage and beyond can be manual tests, deployment into production or other environments. And I bring this out and talk about this because I see a lot of confusion about how you would bring this type of thing into fruition within a service provider's environment. You know, sometimes the later stages include tests of how well stacks of infrastructure work together, and right, so you could have a group of servers, switches, databases, in other words, and any grouping of elements that must be modified all at once, right? So that's a stack, and that's also handled within the continuous delivery, right? So really, the reason why you need continuous delivery is to pull the paint forward, right? And that's really the idea. The more you practice something, the easier it becomes. For service providers, this means preferring software and hardware options that lend themselves to the continuous delivery process. Okay? This means promoting, contributing to, and using open source, open hardware, bare metal switches, and commodity solutions that allow for completely automated deployments that separate, and this is important, separate artifacts from configuration and environments. If you use proprietary software and hardware, it can be harder to automate deployment. So the service providers need to demand the ability to make completely automated deploys with separate artifacts, configuration, and environments from the vendors in order to get the benefits of an agile process. And that's what I think, really what I think when I hear the pain of service providers, that's what I think they need to address and how they need to address it.
Okay, so I know some of you are rolling your eyes right now, and it's like, obviously Watson, obviously Jeffrey, we're supposed to do CI/CD, but what does that actually mean? Especially when we start getting into the CNF space. Once again, thinking about some of the past pain from the SDN and NFV space is, how do I actually integrate my stack into the pipeline as a provider? I think one of the challenges for a telco or cable provider that's different than some of the more enterprise-centric companies is the sheer amount of end environments that we have, and the sheer amount of operations groups, engineering groups, et cetera, that are all supposed to work in concert with each other. And so immutable infrastructure, this is one of the key tenets of a cloud native deployment. But what does that really mean? Especially in the network space, I think that a lot of people, when they hear immutable infrastructure, buzzword bingo kicks in. People start to roll their eyes. I can't have an immutable network. The big second bulleted thing there. Are you telling me I can't add a VLAN to an interface? This is always the first counterpoint I get when I say we should have immutable infrastructure. Is if you're telling me I can't modify my network device, then what good is the network device? If I have to completely nuke my data plane inside of my CNF because you're telling me I need to redeploy it every time I want to make a configuration change, it's worthless. And that's not what we're saying. What we're saying is we have to change how we approach the network. So, you always hear about all these Python for network, classes, this and that. Every network person is going to become a software person. When in reality, A, that hasn't happened. B, we still need people who know BGP way better than myself. People who are pushing the boundaries of segment routing and really getting into the nuts and bolts of what the actual network is trying to give us. But how we provision and consume the network, if we're going to quote unquote do it cloud native, then we have to do it the way that software people attack these problems. Why? Because cloud native approaches are about a shift in paradigm on the software side, right? So if we're going to apply cloud native principles, that means we're going to apply software principles to how we approach our network. And a big thing is if you're modifying any part of your stack in place, then you're not immutable. It's just, if you go and look at what immutable actually means, this is kind of Wasson and I's line in the sand. If you're going in and you're touching a CLI, if you're going into a GUI, once again, this is any part of your stack, whether you're going into Horizon and OpenStack, if you're going into a device CLI, if you're using a vendor proprietary SDN solution and you're modifying things there directly in place, you're breaking the process. So where are we going? One more slide down for me, Watson. There we go. And so how do you actually get to a point where you do have an immutable stack? As you layer artifacts on top of each other, especially in a service provider when you're handing off from one group to the next, this whole concept of infrastructure as code, it also has to move beyond just a buzzword that we use to kind of abstract everything and be oh yeah, I have infrastructure as code, I wrote some Terraform, I have an Ansible playbook, I have a chef cookbook, et cetera. It has to be a complete paradigm shift, especially in a provider. You need to have every single part of your stack defined in code, a template, or an artifact that you can check in version control. So, that means if you were writing the Kubernetes deployment management system, all of that is defined in whichever templating, code, structure, et cetera, that you use, whether it's a bunch of Python that wraps kubeadm up and then allows people to deploy Kubernetes, whether you're doing it through something like Rancher or OpenShift, anything that you're using to do that provisioning, it gets checked in. Conversely, CNFs, network services through NSM, et cetera, everything is defined and checked in. And so what that means is if I need to change something, I always go back to the source, I make the modifications there, I check it back in, and then I let the pipeline do its work. If at any time I'm trying to trump or overcome the pipeline, I'm starting to break several of the tenets within the cloud native philosophy, and I'm therefore starting to reintroduce pain doing things the legacy way. And so, if you treat everything as code, quote unquote, and I always think that that's also kind of a misnomer because, most of the time it's just templates and data models that you're pushing in and checking in to get. But this applies to configuration too. And this addresses that second point of, do I have to nuke my CNF every time I want to change the configuration on it? And the answer is no, right? But what you should be doing is treating the configuration itself as an artifact, right? Figure out your favorite way of, orchestrating something, regardless of what your poison of choice is for tooling. But then all of that gets captured, codified, and checked into source control. So if I have the makeup of, a containerized router, It's got X, Y, and Z routes. It's got these policies configured for AAA. It's got, X, Y, and Z RBAC stuff configured, etc. That entire thing is templated, and it is then checked in. And some of this is going to be imperative, but as we go to the next slide, we're going to start looking at like the spectrum of declarative versus imperative type things. And let me real quick minimize everybody's faces here so I can see the whole slide. But first I'll let Watson kind of describe the spectrum, and then I'm going to talk about kind of how NSM in my mind fits into this and how it enables me, the sneaky network person, how it enables Sarah, the person who's a lot better than I am, and then how we actually start to work with CNF vendors to kind of make some of this magic happen.
Sure. Can you hear me, Jeffrey?
Yeah.
Okay, cool. Right. Had a little technical malfunction in the background for me. So the declarative APIs, they allow us to say what, not how. This is what we say, what the state of the system will be, right? So we want to say this, what the state of the system will be, and not how to get there. The declarative spectrum puts things like the local mechanisms like MIF and affinity decisions to the right of the spectrum with the CNF developers and the operators. The more to the left of the spectrum that you move, the higher the level of abstraction and the more declarative the API, right? And so I'll give it to you, Jeffrey.
Yeah, okay. So why I started watching and keeping up with network service mesh is because of how it, in my opinion, really does a good job of encompassing this entire spectrum. It has a little bit of something from everybody, for everybody, and I feel fortunate to follow the previous presentation, the explanation of systems, network services, services in general, et cetera. But we focus on Sarah a lot in the CNCF space. I'll be honest, most of the time when people see what company I work for, they're like, well, why aren't you hanging out with the LFN crowd? Like, you're tainted. You're just going to try to screw everything up and start whining about subnets here in a second. But in reality, someone has to think about the imperative tasks. Like, these servers don't configure themselves. And the switches, the fabric, et cetera, like someone at some point wrote the imperative automation to create these upper level abstractions. And I would argue that Sarah does things imperatively. She does things imperatively in her applications. As she's building, a portal, for someone to consume, she's putting that entire backend together. She's imperatively saying how she's going to push and retrieve information from the database that's keeping track of all of her customers. But the question is what does she care about? She cares about her application. She does not care about, the network. And that's why people like Ed have decided that, we're going to rescue Sarah from people like me, the person who wants to like overanalyze everything on the network side. And Sarah does this by consuming network services. Once again, the previous presentation did a fantastic job of kind of showing what that is. And she can request it by name, right? If you look at Watson's definition of declarative, Sarah describes what she wants from the network, not how she wants to get it. And this is possible because NSM also provides the concept of building your own network services. You can go in and you can write these definitions. You can decide your order of preference for local mechanisms and remote mechanisms. If I'm a CNF vendor, I can get very imperative with NSM, so that way, the operator there in the middle, who kind of has to wear both hats, can consume their CNF in a manner that is declarative. I can just say, I want X. I can then additionally write my own network services around something like what Frederick was showing. I can now put my own layer of abstraction on there, and every abstraction leaks, that's a fact. But there's the ability to figure out how I am going to, expose APIs to each layer further up the stack. So if I have a CNF that is, truly cloud native, it's composed of microservices, it's immutable once that artifact is shipped, et cetera, I can write a, granular network service that says this is how all the components of my CNF fit together. Conversely, I consume that CNF as a complete package, right? There's going to be an API that's exposed. There's going to be interfaces that I can consume. I can set up virtual wires to and fro, et cetera. I put my network service on top of that, where I'm going to be imperative on how I want my network to run, but I don't necessarily want to have to be imperative on how I set up the CNF. And then conversely, you have Sarah at the uppermost, furthest left abstraction, where she is now able to just say, I want this network service, which is, as you walk your way down the stack, comprised of what the overarching network service looks like, the macro level one at me as the service provider, which is stitching multiple CNFs together potentially. And then theoretically, this could be multiple vendor CNFs of different companies. I can then take their immutable artifacts and directly consume them. And so, this, in my opinion, is a lot different than the way that NFV worked. NFV worked where typically it's like you have to deploy a VIM per vendor because you get into all these weird KPI and SLA arguments. But at the end of the day, I would argue once again, if I have to deploy a unique OpenStack or vSphere environment for every single CNF I want to deploy, well, why am I doing it? I might as well just get the PNFs. And so, network service mesh, in my opinion, it creates bridges between Sarah and the SMPs. It gives me the ability to define the network how I need, and I hand, an FTD in to Sarah that she can just use to request the services she wants, and she can focus on only worrying about the imperativeness in her application. Conditionally too, there's lots and lots of operation groups in the telco. We can now come together, check in a service into source control. We can put the necessary gates in place so everybody gets to, feel like they were included and sign off on it. But then after that, I can go across barriers. I can go across service providers potentially, hopefully someday we write network services that define how I do peering between, myself and one of my peers / competitors, without having to worry about do we each do, X, Y, and Z configuration slightly different, because we're worried about the declarative approach versus the imperative approach. So let's go ahead and jump to the next slide and kind of talk about some challenges here.
Okay. Yeah, so Ed, jump in, give us the 5-minute warning. I'm losing track of time here. So
that's okay. You guys can keep going. I mean, we do have a break coming up after you, but we were sort of clear with folks. We probably were.
Great. All right. So, there are many challenges when applying cloud native principles to networking. One of the many challenges is identifying the requirements from the diverse service provider community. One type of requirement for larger service providers is the ability to procure solutions from multiple vendors. This means that vendors cannot sell solutions that do not play nice with vendor solutions, right? With service provider solutions. So a example of failure, let's say, of implementations in the past would be something like SNMP. I won't say complete failure, but as far as compatibility with the different solutions between vendors, right? So, and then some success stories would be HTTP and say, obviously IPv4, right? And so for me, the development process should be integrated in order to address some of that integration problem. Should be integrated with the procurement process to help facilitate multiple organizations, working with Conway's law and not against it. For larger service providers, this should include automated performance, security, and compliance testing stages in the continuous delivery process. I'll hand off to you, Jeffrey.
Yeah, so yeah, just kind of following up on what Watson says, the first one is big for us. And, full disclosure, I know that service providers, we ask for ridiculous things sometimes, and a lot of times vendors feel like they're herding cats. And I will make that admission, you know, like we sometimes engineer ourselves into corners that are hard to get out of, and you have to rescue us. But conversely, you know, so lots of SNMP is a good example, but like, let's look at netconf and Yang, which, you know, is heavy in the, you know, SDN space. Same thing with the Etsy Nano model, right? Like Souls 1 through 5 really didn't get a lot of love until the last couple of years. So like, I couldn't run, you know, vendor X NFVO with vendor Y's VNFM. It just was impossible. Like even just the whole indirect versus direct model of, you know, where does the network, you know, creation platform live? Does it live in the NFVO? Does it live in the VNFM? You know, go to Juniper, Cisco, Nokia, et cetera. Like they don't describe and model in Yang, BGP, OSPF the same way. So like we need to kind of figure out like how, if we're going to do this in a cloud native way, we overcome those things. And then, you know, Watson touched on Conway's law. I see network service mesh as a means of helping me overcome this. If I'm writing my own system based on how my organizational structure is set up, and I have a bunch of other groups within my company that are doing the same, how do we link our services together? And I feel like the way that network services were described is a good way to do that, right? I can work with my entity, build what I need to build, and then I can potentially work with another group where we describe a service that connects the two of them. Performance, you know, this is like the Achilles heel of any time we're trying to move out of PNFs into VNFs or CNFs, right? Like if I don't get as much speed as I had in the PNF, then, you know, I haven't like hit this nirvana of, you know, virtualization or containerization, et cetera. But really what the question needs to be is, you know, Watson said at the very beginning, you have to like weigh the pros and cons. You know, what am I getting out of this transformation? Like, and is it worth it? You know, how cloud native do I get with, you know, still maintaining a comparable amount of performance from my infrastructure, right? Like if I can only get 10 packets per second out of 100 gig net, then things have gone horribly, horribly wrong. And maybe I shouldn't be doing what I'm doing, right? Conversely though, if I take, you know, a very small hit in performance, but I do get things like elasticity with, you know, an elasticity in the sense that like I have true microservices and those individual services are elastic and I can scale them horizontally, shrink them, you know, basically use my resources on how they need to be used. Last big thing though is scale. And this is one I don't think we as a community have really figured out yet. I don't necessarily think that network service mesh magically makes this go away. But how many clusters do I run? If I go with the legacy model of, you know, 1 K8s cluster per CNF, because you get into these weird issues on resource reservation, security concerns, et cetera. And instead of trying to address those, we just say, you know, vendor, you know, A gets, you know, stack A, vendor B gets stack B, et cetera. But I mean, what's my master to worker ratio, right? If I'm hosting almost as many master and etcd nodes as I am worker nodes, something's gone awry. Like, how much compute am I going to consume? What does this look like at the edge? Am I going to host lots and lots and lots of individual Kubernetes clusters at the edge and burn up all those resources? Let's say I'm doing it in bare metal and I'm not, you know, virtualizing these control plane nodes. Like, all of a sudden, the cost model just completely falls on its face. So I think that this is one of the things that, as we look at, you know, cloud native network functions, if you will, you know, if we're going to say that Kubernetes is the answer, then we need to figure this piece out, or I think, you know, we're going to have some buyer's remorse in the future. And then let's go ahead and wrap it up here.
All right. The one thing I'm going to do is push back a little bit when you said that the network providers are, service providers are a little too pushy. You know, I've worked on medical devices, hemodialysis machines, and so on and so forth. And I'm going to say, you know, if you believe that when your software or your service goes down, people die, then you're not being too pushy. So,
no, that's fair.
You know, I think that people should, you know, I develop through empathy, right? If my user or my end user feels pain, that's what I'm developing too. And when, you know, someone, if there's a certain amount of danger that's involved, you know, I think that is a good driver for people to address that. So push the pain forward and let people address it. So that's what I'm a big believer in that. So as far as in conclusion, CNFs to qualify as cloud native, the ideology behind what it means to in fact be cloud native must be taken into consideration. Simply repackaging network functions in containers and deploying them with Kubernetes will not be enough to give service providers what they want or need. And while NSM might not be the silver bullet, right, which nothing is, it is at least approaching the problem with cloud native considerations at the forefront, as opposed to being relegated to a nice to have afterthought. And I think that's in conclusion. We have some resources here. We have cloud native principles, which are tailored to a lot of what the benefits of to a service provider. And then also we have, as far as testing and trying to evaluate your vendors and your individual projects within your pipeline, we have the CNF test bed link and CNF conformance link as well there for you. And I think that concludes, unless you have anything, Jeffrey.
No, I think that does it.